Right, so today we're going to talk a little bit about something called series circuits, and we're going to be building on some of the ideas from last time. If you recall, we talked last time about Ohm's law, voltage equals current times resistance. And we also talked a little bit about conventional current and some of the basic ideas behind what makes electricity flow. Today we're going to talk about something simple called series circuits, but before we get there, we're going to introduce this new idea, which is actually an old idea of electric power. Power is the amount of energy used in a circuit each second. And the way that you calculate electric power, which is equivalent to power that we studied earlier in the year, is by taking the electric current in amperes times the electric voltage in volts. When you do that, the units that you get to measure power are in watts. You might be familiar with power electrically by looking at the side of a light bulb and noticing the number written in watts. That's a rating of electric power. We're going to talk about this a little bit today. So series circuits are very, very simple because they have a bunch of circuit elements like these three resistors connected in a row, one after another. So for a simple series circuit, there is only one pathway for the electricity to follow, one loop, and that makes things very simple. To find the total resistance is usually what you want to do in order to simplify a series circuit, and all you have to do is add the resistors together. So R1 plus R2 plus R3, or if there was more, you would just keep adding. The reason you do that is because once you find the total resistance, you can easily calculate the current coming out of the battery by just taking the voltage divided by the total resistance. And once you know the current, that's nice because the current is the same here, it's the same here, it's the same here, it's the same everywhere because there's only one pathway for the current to follow, so the current is the same anywhere in the circuit. The best way to explain series circuits is by doing some examples. So here we have a very simple series circuit. You can see 24 volts coming out of the battery, and you can see the first resistor is 5 ohms, and the second resistor is 5 ohms. So to find the total resistance here, all you got to do is add them up. But first, there's some simple rules over here on the left. The first one is that the total voltage drop around the loop in the circuit must add to 0. The second one is that if a resistor is larger than another, it's going to experience a bigger voltage drop. And the last one you already know, the current is the same everywhere. So this first rule, here's what it means. The battery is the starting point. So the battery pumps up the voltage. It adds voltage. So this is a plus 24 volts. Then each time you go across a circuit element, you are going to lose voltage until you get back to 0, and then the battery starts it all over again. This one is very simple. Since these two resistors are equal, they're going to have equal voltage drops. And since there's two of them, you're going to have two drops that are equal in size that have to get you from 24 volts down to 0. So that means that each voltage drop is going to be 12. But before we even get there, let me show you the math. The total resistance is 10 because 5 ohms plus 5 ohms is 10 ohms. And once you have that, now you can find the current. So you take the current equals voltage divided by the total resistance, which is 24 divided by 10, and that gives you 2.4 amps. So let's walk around the circuit and watch how the voltage drops. Up here at the top of the battery, anywhere along this wire, before you get to this first resistor, the voltage is the same. It's 24 volts. Now it's going to go through resistor 1 and it's going to drop. And we talked about how it was going to drop 12 volts. The reason that we talked about it being 12 is because each of these resistors are equal. But let's do the math. In order to find voltage, you got to use Ohm's law, which is current times resistance. Well, the current is 2.4 amps and the resistance is 5. 2.4 times 5 gives you 12. So if you start at 24 volts and you drop 12 volts, anywhere in between these two resistors, the voltage is now 12. Same resistor over here, so now you're going to go through another 12 volt drop to get down to 0. So that's how that works. Now to calculate the power dissipated in each resistor, you would just take the voltage, which in this case is 12 volts across each resistor, times the current. 2.4 amps times 12 volts gives you 28.8 watts. Okay, so that's the first example. I'll do one more. Here now you have a voltage of 30, and here you have three resistors, and here they are not equal. So the first step is the same. You want to find the total resistance. So you just take 10 plus 15 plus 5, which gives you a total of 30 ohms. To find the current, you take the voltage, which is also 30, divided by the resistance, which is 30, and you get 1 ampere of current. Okay, so now if we walk around the voltage loop, you go up 30 at the battery, so anywhere in here is 30 volts, and then you're going to drop down across each of these resistors, but their drops are not going to be equal because the resistances are going to be different here. So now you have to actually do the math. 1 amp, Ohm's law, V equals IR, current times resistance. 1 amp times 10 ohms means this resistor is going to have a 10 volt drop. So if you start at 30 and you drop 10, now you're at 20 volts over here. Now you're going to go through the 15 ohm resistor. Well, 1 amp times 15 ohms will give you a 15 volt drop. So 20 minus 15 brings you down to 5. And then the last drop is 1 amp times 5 volts, or you just go from 5 down to 0. And now you're back to the starting point. You could calculate the power running through each circuit element now, just like we did last time, by taking the current times the voltage drop. That's it for series circuits. Now I'll give you some practice time.